On our two-story building project. Good day. This was our brief for the project. We were to design a two-story steel beam structure with a total floor area of at least 200 square meters. We were to work out the load paths and determine what size the I-beams and girders were required. So this was our initial design of the two-story structure with a concrete slab. This was supported by 3 I-beams and 4 columns. So this shows the concrete slabs and where the girders are on our initial model. So on this slide you can see where the I-beams are located in the design and where the columns are. The columns are square while the I-beams are more rectangular. So from this design we found that this should not be able to hold the weight needed for the floor area. So therefore we will need to add more columns and beams so they will be able to work.
This is our new design. We have 4 extra columns and 2 extra beams. The next part will explain these. As you can see here, these are the I-beams and these are the columns. In this picture you can see the concrete slabs and the girders. For this we use 7 meter long I-beams and a 100 square meter concrete slab, which is 7 meters by 14.3 meters, that's 70 millimeters thick. The girders we used were 14.3 meters long. Here are the calculations for the next design.
To make up the total area required for this project of 200 square meters, each floor needed to be 100 square meters. So therefore we used the minimum length of 7 meters I-beams and 14 meters, 0.3 meters girder, with even spacing between. These are the calculations for the 2 middle beams. To be able to pick up a suitable I-beam, we needed to find beam which will be more than 148 kilonewtons per meter. From the maximum bending load we needed to find a beam which will have the best suited higher maximum bending load design. From a series of beams we found that 460 UB 74 kilo per meter is the most appropriate. Once we found that, we recalculated our design load to include the self-weight of the beam as well. This gave us 153.3 kilonewton per meter, which is still lower than 183.6 kilonewton per meter, so it is still okay. For the outer beams we use the same calculations and we use the same design beams for 60 UB beams. We found that the load beam transferred to the girder, these numbers fitted in well.
So in this section this is how we calculated the girder. For this we used the reaction forces from the beams to the girders. We then found in the course pack a formula to find the maximum moment. This came up with 200.2 kilonewton meters.
Wow, thanks Steve. Then for this section we simply added up the forces on the 3 columns at the top with the 3 columns on the bottom. We only used this method because it's the only way we knew how. We got a total of 146 kilonewtons for the 2 outer beams and 246 kilonewtons for the middle beam. This means that all columns will need to be designed to carry 246 kilonewtons. Thanks for listening.